Assalamualaikum warahmatullahi wabarakatuh. My name is Noor Akmal bin Mohammad. Now, my supervisor name is Dr. Rohani Binti Rahmat. I will present my poster about my project Sarjana Muda 2, which the title is Vibration Investigation on Rotational Pumps at UTHM Biodiesel Pilot Plant. For the abstract part, vibration is an unavoidable reality in machinery and equipment. The research aimed to study the different specification of rotating pumps, vibration in determining the fault occurrence prediction and correlation of temperature fluid to the pump's vibration. Based on ISO 10816 standard, the pump safe limit was identified and the pump operation was decided to continue to run or stop immediately and undergo maintenance. In determining the type of maintenance, the pump's fault was investigated based on the characteristics shown in the Fast Fourier Transform waveform. The experiment shows pump A must stop immediately, undergo alignment maintenance, and change the rubber bush since it generated a vibration velocity of more than 2.80 mm per second, which is the safe limit standard for motor less 5 kW power. In contrast, pump B, C, and D were acceptable to run. For the effect of temperature fluid, 25 degrees Celsius to 70 degrees Celsius was studied during the occurrence of vibration. The result indicate the vibration velocity increased at 4 measured points as the fluid temperature increased. The significant causes of this problem were the lower viscosity of the fluid and the decreasing pump stiffness. For the introduction part, a centrifugal pump in utility area creates huge amount of noise and the concrete base vibrates when the pump is running. The device vibrates in certain degree and became unusual or obvious when the components become older or had tendency to break. The research aimed to study the different specification of rotating pump vibration in determining the fault occurrence prediction and correlation of temperature to the pump's vibration. The experiment was conducted on 4 pumps, which are 3 centrifugal pumps, pump A, B, and C, and a multi-stage centrifugal pump, pump D, at UTHM Biodiesel Pilot Plant. For the literature review, from the previous research done by the Wang et al. In 2022, the study shows the higher concentration of sand causes turbulence in flow that causes excitation force on the pump and sand abrasion on the impeller. From the research by Luo et al. In 2022, the hydraulic vibration generated from the surface of the diaphragm tank due to the viscosity of the fluid. From the research by Mohammad et al. In 2019, for the low frequency of the pump, the vibration analysis is more efficient and acoustic emission measurements are more effective on higher frequency pump. For the methodology part, the procedure of experiment and safety measurement follow according to ISO 10816-1, which are mechanical vibration, evaluation of machine vibration by measurement on non-rotating parts. For the flow of the research, first of all, identify the location of vibration probe, and then the experiment run on 2 different types of fluid, which are first in ambient temperature fluid conducted on pump A, B, C, and D, while on hot temperature fluid just in pump D. After the pump running on hot or in ambient temperature fluid, the vibration measurement and spectrum was recorded. Next, we go to the result and discussion part. As we can see, on the left side is the vibration spectrum of the pump A. From the vibration spectrum, the suspected symptoms are angular misalignment, parallel misalignment, and coupling fault. For the recommendation to cope with the symptom is the realignment back the motor side of the pump and then change the rubber bush on flange coupling to decrease the coupling fault recorded. Next, we go to the pump B. From the graph of the velocity versus frequency, the suspected symptoms are angular misalignment and parallel misalignment due to the 3 type of peak recorded. For the recommendation, realignment back the machine or the motor. Next, we go to the pump C. The suspected symptoms are angular misalignment and eccentric rotor. The recommendation for the symptom is realignment the pump and check the rotor shaft at the motor since it shows eccentric rotor fault. And last, on the pump D, the suspected symptom are flow turbulence, cavitation, and structural looseness. The flow turbulence can we see on the high peak at the first 180 degree of the pump. So, for the recommendation of the symptom is installing an anti-vortex fitting to decrease the flow turbulence and cavitation because it can decrease the amount of bubble in the fluid. Next, check the bolts and nuts at the foundation of the pump to decrease the structural looseness symptom. For the effect of temperature fluid to the vibration, after five different temperature of fluid run in the pump, it was suspected the resonance occurred when the fluid was at 36 degrees Celsius. We can see at the point 3 and point 4 at 36 degrees Celsius, it shows the high velocity measurement. This resonance can be different for all pumps since the states of the wear and tear were not identical to all pumps. Since the first 180 degrees shows flow turbulence, the resonance cannot be detected since the flow turbulence produces more significant frequency than the resonance. In the conclusion part, overall, the vibration self-limit of the pump B, C, and D were in fair condition except for pump A. Pump A needed realignment and changing of rubber bush at the flange coupling. For the effect of temperature fluid to the vibration velocity measurement points 1, 2, 3, and 4 increased by 38%, 22%, 64%, and 21% respectively when the fluid temperature increased. This hypothesis was parallel with the previous research written by Wang et al. In 2022. In this research, it showed the characteristic of the fluid does not affect the vibration spectrum characteristic. So this is the reference part. That's all from me. Thank you.